Hello. Today we're going to be starting section 3.1. Section 3.1 we're going to talk about graphing sine and cosine functions, but before we actually get into the graphing, I want to start with a little bit of the key features about the graphs for sine and cosine. So what we're looking at here below is the graph for y equals sine x. Notice the wave shape that repeats over and over and over again. This type of shape is called a sinusoid. And both the graphs of sine and cosine have similar wave-like shapes. There's three key features to the graph of a sinusoid that we're going to be interested in talking about today. The first one that we're going to talk about is a midline. So the midline splits the graph in half as so. I'll abbreviate midline as ML. The second key feature is called the amplitude. So the amplitude is like the height from the midline to the top or to a bottom of our highest or lowest point on the graph. And then the last one we'll talk about is the period. So the period is the length of the longest non-repeating segment for our graph. So we'll pick some point as like a start. I would say I'm going to pick here at the origin, but it doesn't really matter where you pick. And I notice my graph goes up, it goes down, and then it goes back to the origin to start going up again. So that's like my end. So this distance is one period. So let's start by doing an example at trying to pick out what the midline, amplitude, and period are from some graphs. So our first graph that we're going to look at is this one. So again, what we're doing is we're going to look at trying to pick out the midline, the amplitude, and the period, just from looking at the picture. So the first thing I'm going to do is look to see for the midline. So again, the midline is the line that splits the graph in half. So you have like half of the graph above the midline and half of the graph below the midline. If I look, it appears to me like this would be the midline. So for the midline, we'd say, since it's equation of a line, it's going to start y equals, and it goes through the y coordinate 1. So we just say y equals 1. That's it. Midline. Mostly just using our eyes, right? Okay. So the amplitude was the distance from the midline to either one of these top of the peak or the bottom of like the trough. So like this distance would be my amplitude. So that distance started at 1 and then goes all the way up to 4. So my amplitude there would be 3. And then the last piece I want is my period. So again, I can start my period kind of counting for my period wherever. I usually like to start on the midline or start at like a peak or a valley. I'm going to start here at this point. So I do an up, I do a down, and then I'm ready to start a new up. So that's going to be the end. So we started at the x value 0, and we ended at the x value pi. So the distance from 0 to pi is just, well, the big one minus the little one. It's pi. pretty straightforward. Let's look at another example. So again, we're looking to do the same thing. We're going to find the midline, the period, and the amplitude. So I'm going to go and look here. Usually I like to kind of start looking on the y-axis. And it looks like right about here I have about half the graph above and half the graph below. Right? There it looks like. If you kind of draw a line in and you don't think that's exactly right after you draw it, you can always move it, but that looks right. So if I look at my graph, the scale's going by twos. So 0 is here, 2 is there, so this looks like y equals 1 again. Next we'll go to amplitude. So again, the amplitude is the distance from the midline up to a peak or down to a trough, doesn't matter, or a valley, you can call it that instead of a trough. So if I look at this, I'm looking at my y distance because it's vertical. So I'm starting at, looks like y equals 1 and ending at y equals 3. So the distance from 3 to 1 is just 3 minus 1, or 2. And then my last piece is I'm going to look at my period. So again, you can start anywhere. I like to start on the midline. So I'll start here. I did a down, and I did an up, and then I'm back to the midline, ready to do another down again. So that's the end of my period. So my period started at x equals 0 and ended at x equals 4 pi. So the period is just going to be the difference between those. So 4 pi. Fairly straightforward, right? We're just kind of using our eyes, doing a little bit of counting. Should be pretty simple. What I want to do next is I want to connect these key features to the equation for our graph. So like when we graph an equation for a line, we graph like y equals 2x plus 7. And the 2 and the 7 tell us about the features in our graph. That tells us like the slope is 2 and the or the y-intercept is 7. I want to do the same thing now about my midline, my amplitude, my period, and connect it to the numbers that could be in my graph of sine or cosine. So for any general sinusoid, we say, for example, y equals a times sine of 1 over c times x minus h plus k. Or if we were dealing with a cosine, the letters are all the same in the same spots. The only difference is that it's cosine there. The big three that we care about right now are going to be the amplitude, the midline, and the period, and showing how those coefficients in our equation relate to the values for my midline, my period, and my amplitude. So we just have like 3 formulas there. The amplitude is the absolute value of A, so that's the coefficient in front. The midline is the equation y equals k, where k is the number added to the end. And the period is going to be 2 pi times the absolute value of c, where c is the denominator up front. Okay. So let's start by identifying the A, C, and K from my equation. And after we've done that, we'll use those formulas from above to write the values for our midline, or for our midline, or my amplitude, or my period. So my value for A is, what do we think here? Remember, the A is that number out front, so that's just -3. And then my value for k, we'll save the tricky one for last, is that number at the end, so just 4. Remember, if it's minus, we got to take that negative with us, though. Now, my value for c is going to come from this coefficient in front. But remember, when we wrote our general form, that coefficient in front is 1 over c. So if I want just c, I'm always going to be taking the reciprocal of that coefficient. So I always will want to flip whatever that number is in front of the x when I write my c. Now that I have that identified, I can figure out my amplitude without even having to look at the graph. My formula for amplitude is the absolute value of a. So the absolute value of -3 is just 3. My midline is y equals k, and k is 4, so that's just y equals 4. And my period is 2 pi times the absolute value of c. Well, the absolute value of 2/3 is just 2/3. And then to multiply fractions, I'll think about 2 pi is just 2 pi over 1. And to multiply fractions, we just go straight across. So that's 4 pi over 3. So my amplitude is 3. My midline is y equals 4. Got to write as y equals. It's an equation for a line, not just a number. And my period is 4 pi over 3. Let's try it again. So if we look at this one, so again, A, C, and K is what we're concerned about with today. So remember, again, the A is just that leading coefficient, easy peasy. The K is that number at the end. Notice that's negative this time, so I'm going to take the negative sign with me. And I write that down. And then my C comes from that coefficient on the x. Notice here it's really 2 pi over 3 is my coefficient on my x. But remember, c isn't just the coefficient. I need the reciprocal. So I will flip that to be 3 over 2 pi. Again, the c is always the reciprocal of that coefficient on the x. So now that I have that, my amplitude, absolute value of a, so just 2. My midline is y equals k, so just y equals -1. Got to have the y equals though. And the period is 2 pi times the absolute value of c. Well, the absolute value of a positive is just that number. And when I multiply two fractions, I'll think about that as 2 pi over 1. And whoop, those just reduce down, and I'm left with 3 for my period. Feel okay? One last thing. What if I want to go from my graph to an equation? Let's go back and look at those graphs that we did as examples earlier. So, let's say we have this. We've identified the midline as y equals 1, the amplitude is 3, and the period is pi. Well, I know that y equals k, so k has to be 1. I know that the amplitude is the absolute value of a, so the absolute value of a is 3, so a has to be plus or minus 3. Now, we need to make a choice now, or a decision about whether we think this is positive 3 or negative 3. So what I'm going to do is it'll depend a little bit on whether I want to be writing a sine function or a cosine function. In general, what I'm going to do is I'm going to look at the point at 0. So what's happening when x equals 0? So here, x equals 0 is on the midline. And the first extrema, that's a maximum or minimum, so a peak or a valley, after is positive. So that tells me that the A should be positive here. If that extrema was negative, if it was, or the extrema was a minimum, it would tell me that the A was negative. And if the other option is if at x equals 0 we started at an extrema, if the extrema was a maximum, the A would be positive. And if the extrema was a minimum, the A would be negative. A couple of examples and then we'll have that down. And the last piece is the period. So for the period, we said the period, grab this marker. So the period is 2 pi times the absolute value of c. So my period is pi. So to solve for c, we'll start by first dividing both sides by 2 pi. So the pi's cancel and I'm left with 1/2. And if the absolute value of c is 1/2, that means regular c could be positive 1/2 or negative 1/2. We will always, when we're doing this, choose c to be positive. The A, we have to be careful. That depends on what the picture looks like. Turns out that we can kind of do this in a way that c can always be positive, and that's going to make life much simpler in the future. So I would encourage you in the way I'm going to show you to do this, we will always have positive c. So my last step will be to write my equation. So I have y equals a, and then sine. Now I know it's a sine here because at x equals 0, I'm on the midline. If at x equals 0, again, right there, I was at an extrema, a min or a max, I'd be using cosine. And then I have 1 over c times x plus k. Now, I hate this fraction inside of a fraction. 1 over c is just like a reciprocal, so the reciprocal of 1/2 is just 2. And there's my equation. Let's do this one. Okay, so the midline is y equals 1. That tells me that k is 1. The amplitude is 2. Tells me the absolute value of a is 2. So a is plus or minus 2. So I'm going to look here at x equals 0. I'm on the midline, so I need to look at what happens immediately after. So I'm looking, aha, that's a minimum afterwards, so I know I need negative 2. And then for my period, I know that the period for pi is equal to 2 pi times the absolute value of c. I'll divide both sides by 2 pi to solve for c. And then I know the absolute value of c equals 2 means that c could be plus or minus 2, but we're always going to take a positive c, so that I have my values for a, c, and k. I can write my equation for my function. Again, since at x equals 0, my equation is on the midline, I know I'm going to be using a sine function. The a is negative 2. 1 over c is going to be 1 over 2. And then I write my x, close my parenthesis, and then plus k. Again, when I'm writing these formulas, my template, is these equations down here. Today, the h is always going to be 0. We won't see any h's for right now. That'll come later, but for today, the h is always going to be 0. So in your homework, it's a delta math assignment. You're going to be doing things like looking at a graph and picking out the amplitude or the midline or the period, or looking at an equation and picking out or determining what the period is or the amplitude or the midline, or looking at a graph and filling in the A, C, and K into the formula. And the last thing that we might have to do is say we have like, an equation where the amplitude is 2 and the midline is 5 and the period is 3 pi. So doing this, if we want to write an equation for this, well, the amplitude just tells me that A is plus or minus 2. It doesn't give me any more details, so either answer is going to be fine. We just can pick either one. I'm just going to pick the positive because one less negative sign. The midline is at 5. That tells me that the K is 5. And the period is 3 pi, so that tells me 3 pi is equal to 2 pi times the absolute value of C. Divide both sides by 2 pi. The pi's cancel. And since it's the absolute value of C equals 3 over 2, I know that C could be positive or negative. Doesn't matter which one, because I haven't given any other details about what's going on with the graph, so I can pick either one. I'm just going to pick the positive. So y equals A. Again, no details, so I can pick either sine or cosine. It doesn't matter. I'm going to write sine. 1 over C, so that's the reciprocal of C, so I'll write 2/3, x, and then plus k. Dunzos. Those are the kind of problems you're going to see in your delta math. That'll be due next Sunday, but please use your time today and work on that and make a lot of progress. So it's one less thing we have to do next week. These skills that we're working on today are really fundamental. We're going to add stuff on top of this. So you really want to have a good understanding of like how to look at the graph and pull the values or find the midline, the period, the amplitude, and know how those numbers relate to the coefficients in our equation, which is what we're practicing today. I'm done. Bye-bye.